Now, I did put some quick steps in here because the reservations of resources are incredibly important. I have looked at more than a couple Sky instances where they were underperforming, and the first thing I check is the reservations. And when I see reservations aren't set, we can then start digging into the VMware logs and we can say, okay, well, this should have 62 gigs of RAM, but the balloon filter has pulled 50 gigs of that away to another VM, hence the underperformance. So this is a screenshot of your actual ESX console. It looks very similar in the web view as well. Now, obviously, we need the machine powered off. In a lot of these regards, Sky acts just like a regular VM. If we want to start changing things around, we really need to shut it down first, so that when we bring it back up, the config file for that VM is reread and the proper resources are allocated. In here quickly, we go over reserving CPU. Now, a quick tip here, when you are reserving your CPU, your virtual processors, if you have the ability to do so, I would recommend assigning it cores from different physical sockets. Now, why would we spread it out? Well, really what it comes down to is bus lanes. So if we have 8 cars and we're trying to get those 8 cars down the highway and we have a 4-lane highway, then we end up with 2 rows of cars, 4 cars wide. And that represents the workload going from the VM to a single socket hosting all cores. If we spread those cores out, say we've got a dual or quad socket node, and we're talking physical hardware, if we distribute those cores across all 4 of those sockets, now instead of 2 rows of 4 cars waiting in queue, we now have 4 rows of 2 cars and nobody's waiting, and we actually have enough room to move other traffic because we've still got 2 more lanes open. So if you are able, split those cores out among physical sockets. And of course, each core should have 2 gigahertz minimum, and I'll emphasize minimum. You can always put in a little bit more. If you want to get the numbers that we tell you that you'll get, it really has to be 2 gigahertz, and it really has to be reserved. Now, disabling ballooning, these instructions are actually not that easy to find because all of the best practices in VMware say that you should enable the balloon filter. But for some of the reasons I mentioned earlier, we don't want this Sky appliance to have its resources taken and given to another VM. So we are going to disable the balloon filter here. Again, we need to make sure that the VM is off. And then from there, real quick, right click, go into settings, and under the advanced tab, you can see here under configuration parameters, there is one manual step, and I'm going to show it to you. When you click that, you're going to get this window open here. This schedmem max mem control line will not exist in your config. You're going to need to click add row, as I've noted here with the arrow. And you'll see in orange, that is the line that you're going to want to add to the configuration parameters. This can be scripted. You can do it via the VMware API. I'm not really going to get into some of the VMware CLI stuff today. We'd be here for about 3 hours, and I'll try to get you out of here in about 60 minutes. So you can also do this on the host. Again, that's kind of a use case specific thing. Windows, you can go in and you can tell it, if this machine is virtualized, don't allow any ballooning against the resources. But really, this is the most accessible way to do it. And again, VMware's got a wonderful knowledge base, and they've actually got some templates that you could use to script the addition of this property to a certain list of VMs. So if you're going to do this at the host level and you had 100 hosts that you needed to add this to, VMware does provide some automation to run this in the background in a script. Okay, so why do we need all of these reservations? All right, so for memory, dedupe is going to try to claim a certain percentage of the memory made available to it. If there's no reservation, it's going to actually start to try to page cache into dirty page files. Now those are page files on disk. We really want to force that cache to stay in memory because as soon as we start writing to disk, we slow down and we're so transactionally active. I'm talking 5 figures, 10,000 transactions a minute, and that's pretty calm. It can go much, much higher than that. If you just have to start making all those reads and writes from disk instead of memory registers, you're going to notice a huge hit in performance. Now, dedupe also will determine how much page caching can be done by querying the VMware API to say, how much memory do I have reserved? And just some round numbers. Let's say, okay, Sky, you have 10 gigs of memory. Dedupe looks at it and says, okay, I'm going to need 3 of those. So the rest of the machine can contend for who gets the last 7. Well, if we don't give it a bounded limit, like I said, then we start writing into disk, and we don't want to write to disk. We want to stay in memory. And the way that works out is, as you can see, the bottom bullet under memory, swap file equals configured memory minus memory reservation. So if you have a VM, Sky VM, configured for 16 gigs of memory, but you've only reserved 8 gigs of memory on boot, that VM will create an 8 gigabyte swap file on disk. And again, for the highly transactional nature of things like deduplication, we don't ever want to write to disk until we're done. We want to do all of our work in memory. And then once we've finalized the deduplication job, then we write it to disk. Next is CPU and bus optimization. That's the analogy I provided about the cars going down the highway. You can only fit 4 cars across the highway in a 4-lane highway. Splitting up, reserving those cores and splitting them among physical sockets essentially allows you to be the traffic cop and only send a couple cars down each road, making sure you don't hit any congestion. Now, this will also prevent queuing of IO requests, which again, we're very highly transactional. A little bit of queuing is okay. We don't want to see kind of chronic queuing or extended queues though. And dividing up your traffic across all these bus lanes helps prevent that. Now, this also makes sure that the dedupe engine has enough horsepower to deliver the throughput that you need. Now, if you're expecting 7 terabytes of dedupe ingest and processing a day, but you only give us 1.5 gigahertz of processor, you may be short a core and you don't reserve anything, I'm going to predict your throughput is going to be closer to 1.5 to maybe 3 terabytes a day. So all of these reservations, if you want to make the performance metrics that we talk about, these reservations are really essential. The balloon filter, we've kind of covered that briefly already. This is going to prevent resources from being pulled away from Sky and sent to other VMs. If we write to a memory register, but then we let it go inactive because we're just letting it sit there as a cache file, this will prevent VMware from pulling those memory registers out from underneath us and causing us to essentially restart the job. And then, of course, it just ensures that we've got the throughput that we need to do the workload that we tell you that we can do. Okay, so we've got our test VM set up, our Windows, or in my case, a Debian VM. There's a bunch of tools that we can use at this point. We've got disk attached, we've got our reservations in place, we've got everything built. All we're really missing is the Sky software. But what we need to do first is let's make sure that we're going to install Sky in the right place using the right storage. So there's a ton of tools, and the reason I choose Debian is because I feel like Linux really has the best system monitoring tools. If you happen to be a PowerShell guru and you know of much, much better ways to do it in PowerShell, please go ahead and use PowerShell. It doesn't have to be Linux. It just needs to be a means to an end, and that end is being able to, with some accountability, verify that we're going to be putting Sky into the right place. Now, over here on the right, I've included 2 of my favorite commands, and those are the SAR commands. It's System Analytics or sysstat commands. Very easy to yum or apt-get these packages down. And there is an equivalent on PowerShell as well. It's not quite as robust, but it does exist. Now, we're going to run these from our test VM before we ever install Sky to make sure that our container, our VM container, is in the right place and has good pathing to storage, and we're going to see good performance metrics. So the first command we're going to run is going to be sar-b, and then we're going to follow with the sar-d. These are very well documented commands. I don't want to read the man page aloud to you, but just 2 of the most important metrics that come as output of those are highlighted here. Now for sar-b, your await and your service time, that, people debate the validity of await. So if we are looking at your average wait and we're seeing a discrepancy of a couple of milliseconds, I would kind of discount that. Await can, however, tell us if we've got something big wrong. So if we see a request go to the disk and we see the await returns a value of 300 milliseconds, that means that we were waiting for 300 milliseconds on storage. And as I mentioned before, when we're talking about 10,000 transactions per minute multiplied by 300 milliseconds wait per transaction, you can see how that can add up and certainly hurt performance. Now under SAR-D, this is going to be more network-based than storage-based. Again, it gives a ton of output. I've just kind of highlighted the two that I generally look at first, and that's the average queue size. We talked a little bit earlier about process queuing and bus lanes and whatnot. This is going to be similar, but instead of going to the kernel or the socket, this is actually going to be going to the storage. Now, a little bit of queuing is okay. We can see the average queue dash size, and a little bit's fine. However, if we run this command and we see the average queue climbing and climbing and climbing and never really relieving, that tells us pretty definitively that we've got network congestion. Now, the percent utilized, that's going to be how much CPU time was being used at the time that the request was made. Maybe we set a CPU, but we forgot to set the reservation. Very easy mistake to make. We could find that here in the utilization going to 100%, showing absolute saturation of the virtual processor that's been assigned. Now, where these are system tools, they're not Actifio specific. They're not going to give you an error code that you could reference in our knowledge base. But at this point, we're still very much just dealing with a VM, nothing Actifio specific at all. So all of your sysadmin, DevOps, network administrator skills are still all fully in play here. We're just treating it as a VM at this point. Another two that I do like is IOTOP and iPerf. Generally, if I get output that I'm not happy with or that I'm not convinced by when I run SAR-B or SAR-D, I'll then follow in with IOTOP and iPerf. As some of our sysadmins joining us today will know, it's not always a single error that tells you what's going on. It's kind of a collection or aggregation of facts that you get from these different tools, and you put them together and make an educated decision about what you're seeing in your environment. Once we get to the actual Sky appliance itself, we are going to get some very specific errors that are referenceable and very easy to just kind of address and take care of. However, at this point, while we're qualifying the environment, you really just rely on your Linux or Windows PowerShell skills to go in there and query the environment to make sure that we're setting it up right, and to then understand and chase down any issues that we may find. Now, if you are chasing down these issues and you're getting ready to install Sky, you're an Actifio customer, and you've just run into a dead end, you're beyond your area of expertise, or you're just stuck for whatever reason. That's why we've got our maintenance and support contract. Gather all the information you've gotten so far, open a case with our support team. If you don't have the information, that's okay, but that means they're going to then need to go in and run all these tests themselves. So to speed resolution, if you just document all of this stuff while you are kind of working through the process, if you do hit a problem, you can include that documentation in your support ticket, and that'll help us get it resolved much, much faster. Now over on the left, I've got some external tools. I don't cover all of them. I just wanted to kind of show that there are a lot of tools that we can use for this purpose. The one that I'm going to kind of champion today is going to be VMware IO Analyzer. It's a fine tool. It will do everything that we need to do for this. If you are a VMware customer, it is free. You can just go download it. It's yours to take, which is the big reason for my kind of getting behind this one. Is a zero cost solution that ticks all the boxes tends to be the right solution. However, if you have a preference, if you have SolarWinds, ServiceNow, ManageEngine, any of these other VMware monitoring suites, they also have the tools. No need to install an additional tool if you've already got SolarWinds running in your environment. You could just leverage SolarWinds to kind of give you some performance metrics on the Sky or on the VM that will be hosting Sky soon. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.